As all seafarers know, ballast water is essential for ship stability, compensating for changes in displacement as cargoes are loaded or discharged. It also helps control trim, list, and stability, and minimizes stresses on the ship's structure. So, for centuries, ballast water has been loaded in one port and discharged in another, often on the other side of the ocean. However, about 30 years ago, it began to emerge that it wasn't only water being ferried across the seas of the world. Various organisms were also being transported and released into new environments, where they sometimes thrive with devastating consequences. Take the tiny zebra mussel. It looks fairly harmless, but when transported to an environment such as the Great Lakes, where there are no effective predators, it multiplied remorselessly, affecting local shellfish populations and forming massive colonies that blocked power station water intakes. The costs of countering it were in the billions of dollars. Ballast water has also carried deadly human pathogens like typhoid and cholera, resulting in serious outbreaks of disease. To combat the problem, regulations were established by coastal states which required ships to exchange their ballast when they were in mid-ocean. However, not only can ballast water exchange pose risk to the structure and stability of a ship, it has also become clear that exchange in itself doesn't fully eliminate the risk of undesirable organisms being transferred. Only comprehensive treatment of ballast water can hope to achieve this.
The Ballast Water Convention is actually going to make it mandatory for ships to have treatment systems on board. And those treatment systems will be to a specified standard, which scientists have agreed that will reduce the risk of invasive species. It'll work for all ships that are in international voyages that are over 400 gross tons and have more than 8 cubic meters of ballast.
Sediments, too, are covered in the convention.
If you go into a dry dock, often you do find, realistically these days, there are sediments in the bottom of the tank. Usually up to this point, they've just put them into the water. Well, now they're going to be recognized as what they are, and that's essentially homes for lots of invasive species. So if you come ashore, you're doing repairs, you're going to have a reception facility.
So, seafarers will rapidly need to become familiar with new systems and procedures for managing ballast water on board their vessels. A number of equipment manufacturers have developed such systems, which have then undergone testing procedures to ensure they can achieve the required standard. All equipment systems supplied by manufacturers must be type approved by a flag state, often by a recognized organization on their behalf, to deliver ballast water of an approved standard. The standard the ballast water must meet, known as D2, is defined in the IMO Ballast Water Management Convention and specifies the maximum number of viable organisms permitted in a cubic meter or milliliter of water, according to their size. One of the key challenges in ensuring the standards are met is in the detection of viable organisms after any treatment. Testing requires laboratory facilities where the samples can be examined through microscopes, but a number of online monitoring techniques are being developed. The certification testing begins on shore and then continues on board ship. The equipment must be tested and achieve the required standard, whether the water is fresh, brackish, or saline. US testing protocols are slightly different. The USCG has not formally type-approved any BWM systems, but has given some type-approved systems the status of an Alternative Management System, AMS, which can be used in US waters for a period of 5 years after the USCG implementation date for the specific ship. Individual US states may also implement their own regulations. But what about the timescale? How soon will ships be affected?
In the U.S., we have a slightly different schedule. They are using the first dry dock after 2016, and they have a different schedule for certain sizes. So, for example, things between 1,500 and 5,000 gross tonnage for their ballast are going to have to fit as of a 2014 cycle, and the rest of the ships would be on a 2016 cycle. Ships that have been built under the 1st of December 2013 will all have to be fitted. They would be considered new ships.
So, in the next few years, up to 60,000 ships may need to be fitted with ballast water treatment equipment. This is easier to plan with new builds. But older vessels will have to be retrofitted in order to comply with the new regulations when they come into force. For many ships, particularly smaller ones, fitting in large items of equipment can be very hard, so this is another big challenge.
This is a very complex issue, and in terms of selecting the right and suitable equipment for a ship would only apply to the individual ship. It depends on the ship's size, the ship type, the ship's age, and the ship's trade. Owners have to be very careful doing this. And it's not only a normal risk assessment, it's also a cost-benefit risk analysis.
Ship owners and operators will be faced with some difficult choices, given the many different systems and manufacturers. Factors to consider will include cost, space requirement, power usage, other running costs, complexity of operation, safety considerations, the potential effects on tank corrosion rates, and the potential discharge of harmful substances. For tankers, the systems will need to be intrinsically safe if they are not housed in the ship's safe area. So what's the first thing that ship owners should do?
Go to a number of manufacturers and to get all their information, especially in terms of the test carried out in connection with type approval, being under the IMO or under the US regulations. Because these information will clearly indicate in which conditions certain equipment will be able to be compliant.
There are now many different systems that have gained type approval, but the majority comprise two stages of treatment, with a separation stage followed by disinfection, though some disinfection technologies are used without the need for separation first. Separation means removing the solid material, including larger organisms in the ballast water. This may be achieved either by sedimentation, allowing the solids to settle by virtue of their own weight, by using a hydrocyclone, which operates by centrifugal force, or by filtration. In this case, the holes or pores in the filter are smaller than the size of the sediment or organism. Most filter systems are cleaned automatically by a back-flushing process. The next stage is to disinfect the ballast water, either by a number of different chemical treatments or by a range of physical treatments. Chemical treatment can involve chlorination by adding chemical compounds, electrochlorination where the chlorine is generated by electrolysis, or use of other biocidal compounds. Where the water has been chemically treated, it may be necessary to neutralize it as the ballast is discharged, to avoid harmful effects on organisms where the ship's ballast is being discharged. Chemicals supplied for ballast treatment must also be handled and stored carefully in accordance with the material safety datasheet, so as to avoid any health hazards for the crew. Physical methods include irradiation with ultraviolet light, ultrasound, cavitation, or deoxygenation to asphyxiate the organisms. For more details of the different systems, refer to the workbook which accompanies this program. With many of these systems, ballast water flows through the treatment plant as it is taken on board. This is known as in-line treatment, but it may not be appropriate for ships with very large ballast capacities. In some cases, ballast is treated internally after it has been taken into the tanks. Following internal separation, systems may make use of the ship's inert gas plant for the physical disinfection stage. For a cruise ship, the ballast throughput is relatively small, and an in-line system works very effectively. In 2003, the Coral Princess was fitted with such a system, which uses filtration and UV disinfection to meet the D2 standard. The system has two main components: an auto back flushing filter and an inline UV system. During ballasting, the flow is processed through the filter and UV system and then back to the main ballast system. During deballasting, the filter is bypassed and the water flows only through the UV system and then overboard through the discharge line. Whichever system is installed, a high level of record keeping for ballast water management is mandatory to verify the system is operating correctly and ensure compliance with the new legislation. In particular, any accidental or exceptional uptake or discharge must be recorded. The BWM Convention specifies the information that must be recorded and indicates how the record book should be laid out. IMO has also developed guidelines to assist governments, ship owners and operators, masters, port authorities and other interested parties in implementing the convention. The shipping company and the master must ensure that a practicable ballast water management plan has been developed, one that's comprehensive and realistic in its operation. The plan must be specific to the ship and must be approved by the administration. It should cover relevant safety procedures and designate an officer in charge of ensuring the plan is properly implemented. The plan must also detail the procedures for the disposal of sediments at sea and to shore. Crew training in the use and maintenance of these systems will also be a key issue in ensuring they continue to comply with the standards required. Ship operators may decide to schedule sampling at regular intervals to ensure the system is performing to the standards required, so they can demonstrate compliance. Compliance with the Ballast Water Management Convention will be enforced by Port State Control officers.
The only difference from the regular port state control regime is that for ballast water, you probably have a four-stage process. You have an initial inspection. That's the document check. You look for a ballast water management certificate to make sure the ballast water management plan has been approved by the flag state. You look at the ballast water record book. You make sure that the crew and the officers that are designated for the ballast water system, they know what they're talking about. They actually know what that black box is down below and that it isn't covered in a tarp and has never been used. If things don't look so good, similar to a normal port state control, well, you start looking. You want to get more specific on those things. You go down, you want to make sure that all the lights and the alarms on the system are working. You talk to the engineers to make sure that the ballast water record book hasn't been falsified. Make sure that there aren't any bypasses and things like that. If you are not happy at any point, you stop the discharge. It's not an enforcement action. You may end up asking them to fix the problem. You may do all sorts of the normal port state control things, but when it comes to ballast, the biggest issue is to protect the environment. So the first thing you do is stop the discharge. If all those things are happening and you're still not happy, the other thing that the Ballast Water Convention allows you to do is do sampling.
If there are serious deficiencies, then detentions may result, leading to delays and considerable extra costs being incurred. There is a challenging period ahead for shipping company management and crews as they get to grips with the new ballast water management systems and understand and implement the legal requirements. Meeting these challenges will ensure that ballast water can, in future, be handled safely and with fewer adverse effects on the environment.
Everybody needs to know why are we doing this. Everybody has to know how to operate, maintain, and also ensure monitoring of compliant operation.
Since 2006, in the Great Lakes, we have not had an invasive species attributed to ballast water, and that's very much thanks to the efforts and the joint efforts between Canada and the United States.
The key points to remember are that a ballast water management plan needs to be drawn up and the crew trained in its operation. Type-approved management systems will need to be installed and properly maintained. Detailed records will need to be kept. For further information, please consult the workbook that accompanies this program.